Hi everyone and welcome to Chemistry Simplified with Rosaline. Our today's lesson is classification and naming of carbonyl compounds. Classification and naming of carbonyl compounds. They might seem confusing at first, but I tell you it is super easy to identify them. The key to identifying the family of carbonyl compounds is identifying the structure, the carbon atom bonded to an oxygen atom. Like we can see, a carbon atom is bonded to an oxygen atom. This is where it tells us that we are dealing with carbonyl compounds. Whenever you see this group in any compound, just know that you're dealing with a carbonyl compound. There are so many carbonyl compounds. It is attaching, like you can see the carbon here. The carbon is open at the two ends. Is the group that will be attached to this open chain that will give us the different carbonyl compounds that exist. So we are going to write our base formula. We are going to write a carbonyl group that's attached to a methyl group at this end. This is a methyl group, and on this other side is this R. It's changing of this R that will give us the different carbonyl compounds we have. This is the formula we'll be working with. I also want you to understand that where we have the methyl group in the formula we'll be using, you can have an ethyl group with 2 carbon atoms. You can have a propyl group with 3 carbon atoms and a butyl group with 4 carbon atoms, depending on the length of the compound you want to form. We are working with methyl because methyl is the simplest of them all with just 1 carbon. So we are going to be changing the R. This one we have circled, the blue, the one in blue. We are going to change the R to form our different carbonyl compounds. Let's start with the first one. When R equals hydrogen, we have an aldehyde. An aldehyde ends with the name al. When R equals 1, that gives us an aldehyde, and the name of the aldehyde is going to end with al. All the aldehydes, they have their name ending with al. Any compound that has the name ending with al is an aldehyde. Let's look at an example. This is the example we have. We are going to copy out our methyl group. We are copying the formula the way it is. We are copying our boxed formula, and we are going to replace our R with hydrogen. We have replaced our R with hydrogen, and that is the aldehyde functional group. The one we have circled is the aldehyde functional group. Now let's proceed in naming the aldehydes we have written. We have noticed that there are 2 carbon atoms in that aldehyde, the carbonyl carbon and the carbon atom coming from the methyl group. And when we have 2 carbon atoms, what is the name? The name begins with ethane. So we are going to have an ethanol. An ethanol because of the 2 carbon atoms. If it is 1 carbon atom, we should have methanol. But here we are going to have ethanol because of the 2 carbon atoms. And the name is ending with nal because we are dealing with aldehyde. Let's look at the second example. With the second example, we have replaced our methyl group with an ethyl group. Ethyl because we have 2 carbon atoms. And now when we combine the 2 carbon atoms and the carbonyl carbon, we are going to have altogether how many carbon atoms? 3 carbon atoms. And when we are dealing with 3 carbon atoms, we are 3 carbon atoms, the name should be a propane. Propane, 3 carbon atoms. So we are going to have propanol. Instead of propane, we should have propanol because it is an aldehyde. Also notice that aldehyde functional group occurs at the end of the chain. You can never see an aldehyde functional group in between 2 carbon atoms. It is always the first carbon atom that carries the functional group because we give priority when naming to the first carbon, the carbon that carries the functional group, we label it as carbon 1. Let's continue with the second functional group. We are still going to replace our R in our formula with an alkyl group. What is an alkyl group? An alkyl group is a methyl group, an ethyl group, a propyl group, a butyl group, a pentyl group, and so on and so forth. But for this example, we are going to replace with a methyl group. And when you replace your R with an alkyl group, it gives you a ketone. When your R is replaced with an alkyl group, be it a methyl, ethyl, propyl, or whatever, it gives you a ketone. Let's look at an example. We have our methyl group as before, our carbonyl functional group, and we are replacing our R with an alkyl group, preferably a methyl group. So this is our ketone. And the name of all ketones ends with on. So let's count the number of carbon atoms we have. We have 1, the carbon at the methyl, the carbonyl carbon, and another methyl. So there are 3 carbon atoms in this compound. And since there are 3 carbon atoms, like we said, it is a propane. But we are not going to call it propane because it is not an alkane. It is a ketone, and the name should end with an on. So we name it propanone. Let's look at the other example. We are going to have another example. Notice that we have increased the chain from methyl to ethyl, and we still maintain our methyl group here. So what do we have? We are going to have butanone. We are going to have butanone because if we count the second example, we have 4 carbon atoms, and these are their functional group. A carbonyl carbon bonded to another R, another methyl, ethyl, or propyl. So the rule here is just increasing the number of carbon atoms for the R. The R that you are attaching to the carbonyl carbon, you just increase the number of carbon atoms depending on which ketone you want exactly. We should also note here that unlike the aldehydes that had their functional group at the end, ketones have their functional group in between 2 carbon atoms. The carbonyl carbon is between 2 carbon atoms. So you can never see a carbonyl carbon at the end. It's always between 2 carbon atoms. That's the difference. Let's move to the third functional group with the carbonyl carbon. We are going to replace our R this time with OH. When R is replaced with OH, we have a carboxylic acid, and the name ends with oic acid. When R equals to OH, we have a carboxylic acid, and the name ends with oic acid. Let's look at an example. This is our example when we replace our R with OH. We have our methyl group and our R has been replaced. So this is a carboxylic acid, and we have seen the functional group cycled. How can we name this carboxylic acid? We remember that the name for carboxylic acid ends with oic acid. Now, how many carbon atoms do we have? When counting the number of carbon atoms, we start with the carbon atom carrying the functional group, which is carbon 1, and then we proceed to the methyl carbon, which is carbon 2. When we look at this compound, we see that we have 2 carbon atoms. So 2 carbon atoms is methane. And since it is not an alkane again, it is a carboxylic acid, it will be methanoic acid. So this compound is methanoic acid. Let's go to the next one, the second example. This is the second example we are having. And if we start counting the number of carbon atoms, we'll discover that there are 4 carbon atoms, beginning with the carbon with the functional group, this one here. When we count, we'll see 4. How can we name it? 4 is butanoic acid. That is how we name those functional groups. I also want us to note here that just like the aldehyde functional group, always occurring at the extreme of the chain, it is the same with carboxylic acid functional group, always at the extreme. The carbonyl carbon is always the first carbon, and it doesn't occur in between 2 carbon atoms like the case we have for ketones. To have different carboxylic acid, the rule here is increasing your carbon chain and attaching the carboxylic acid functional group at the end. Let's write on with the 4th one. When R equals to NH2, what do we have? This implies it is an amide, and amide ends with the name amide. When R equals to NH2, we have an amide, and amide ends with the name amide. Let's look at an example. This is our example for the amide, replacing our R in our box formula with NH2. This is it we have had. And how do we name this amide? Ethanamide. We name it ethanamide because there are 2 carbon atoms. If we count the number of carbon atoms in this compound, there are 2, which is ethane. 2 carbon atoms, ethane. And since it is an amide, we give the name ethanamide because it is not an alkane but an amide. And if we want different structure for the amide, we can increase the chain at this end, and then we have different structure: butanamide, propanamide, and so on and so forth. Let's move on to the last but not the least. When R equals to OR, or another R again, we have an ester, and the name ends with oat. We are going to look at example when R equals to O bonded to another R. Let's look at what we have here as an example. We have a methyl group bonded to a carbonyl carbon and our R, a carbonyl carbon, and our R is going to be O with another R. This other R here can be a methyl group, an ethyl group, or whatever it is. It depends on you. This other R in red, you can replace it with a methyl group and ethyl group. But in this tutorial, I use the simplest R we can have, which is a methyl group, a methyl group. It can be an alkyl group, a propyl group, or a butyl group. This is our ester. And how can we name this ester? We name the group attached to the oxygen atom first, which is methyl. This group that is attached to the oxygen atom, it is the methyl group. And then we proceed in naming the carboxylic acid substitute. This way we have our carboxylic acid substituted with 2 carbon atoms. And since there are 2 carbon atoms, the name has to start with ethane. And since it is not an alkane but an ethanoate, but an ester, and the name ends with ot, we are going to have ethanoate. So in combining the 2 names, we are going to have methyl ethanoate, and that is the name of this ester. Remember that you first of all name the group that is attached to the oxygen atom first before naming the carboxylic acid substitute. This brings us to the end of our video, and if this video has helped you learn something about carbonyl compounds, please give it a thumb up, subscribe to this channel for more amazing chemistry concepts like this one if you did enjoy it. Thanks for watching, and I will see you in our next video.